Right, guys, we're gonna dive straight in. We have got two visitors coming today, all right, and they actually were visiting two of the schools yesterday. They're going to be with us a little bit later, and we'll introduce them to you when they arrive. Okay, so we're gonna dive straight in, and this first question is in some data handling, right? And we've got two box and whisker class, two box and whiskers, one for class one, one for class two. Maybe we can just, while Ruth's not here yet with the microphone, we can just shout out the answer. Okay, so for the median mark for class one, 60, okay? Remember the median is this line over here. Okay. The interquartile range for class two, right? So class two, we talk about the interquartile range. Maybe you just want to pop your hand up and you can even just, okay, Ruth will come to you. There we go, you're on row two there. The interquartile range for this one. Now one. Yes. 80 minus 53. And what did you get? 27. Okay, well done. Great start. Guys, if you, just in terms of exam technique, I think for this question, if you just write 27, okay, you will get both marks. But, and here's quad right, just listen very carefully. If you just read this wrongly, or you knew it was 80 minus 53 and you thought that was 26 and you just wrote 26, how many marks are you going to get now? 0. Okay, so it's a very good idea to show this working. Even this will get you what we call a method mark. So even if you just write that, you're going to get one of the 2 marks because you know what the method is. Okay, so in everything we do, we're going to try and show working. All right, then talk to us about the skewness or the symmetry of the data. Is this data symmetrical or is it skewed? And if it's skewed, how is it skewed? Anybody? Is it skewed? Is it skewed positively skewed, negatively skewed, skewed to the right, skewed to the left? And why? Okay, put your hand up if you know. Surely someone knows. Yeah, we've got some more people online and hopefully some more will join still. Right. Well done. It's positively skewed for both of them. Can you tell me why? Okay, I'm going to correct you there. All right, the other name for positively skewed is skewed. Right, now I want you to listen very carefully to what this learner said. She said there is more data to the right, i.e. The median is in the middle. Hey? There's not more data to the right. There's exactly the same amount of data left and right. But what do we know about the data on the right? It's more spread out. Okay, so the reason that it's positively skewed is that the data above the median is more spread. More spread than below. Okay, and just an important idea here, guys. If data is positively skewed, then your mean will be bigger than your median. Okay, so that's worth just writing down here. When data is positively skewed, your mean will be bigger than the median. And when data is negatively skewed, in other words, the mean would be somewhere here, right? Okay, where data is negatively skewed, the mean would be less than the median. So well done, all right? And let me tell you that the answer you gave about more data above, all of the boys that I teach, they always say the same thing. Understand, Q2, the median is the middle of the data. Then it says, what's the value of P if 75% of the candidates in class 1 achieved a mark bigger than P? Okay, so we're talking about 75% of the data. Now, where will 75% of the data, how are we going to answer this? What do the quartiles tell us? The quartiles tell us about 1/4 of the data. What's 1/4 as a percentage? 25%. So we're looking for what mark do 75% of the people get more than that mark? Anyone, put your hand up. Guys, this is 0%. This here is 25%. The median's at 50%. Q3 is at 75%. And the maximum's at 100%. Okay, that's how these quartiles work. All right. So, what mark do we have that 75% of the learners get more than that mark? In class 1, 75% of the learners get more than that mark. Sure, guys. This is 25%. What's this mark over here? 54. Guys, do you see that 54% is where Q1 is? And that's the first quarter of the data. So 75% of the learners get a mark bigger than 54. So P equals 54. All right. Which class has the greatest standard deviation? Now, put your hand up, and I want you to also explain why. Why does one of the classes clearly have a bigger standard deviation? What does standard deviation tell us? What does it tell us about the data? Sure, guys, I hope when our visitors come, you're going to answer some questions. Yes, mind you. No one's answering questions. So where's Mr. Shumule? Okay, you guys normally answer questions. Is Mr. Ngubeni here? Okay. Okay, guys, which data? Okay, standard deviation tells us about how spread out the data is. Which data is more spread out? Class 2. Class 2 will have a bigger standard deviation, all right? And the reason is because the data is more spread out. Okay, all right, we're waking up. Yeah, much. All right, let's pendule kasi. Okay, now I want to talk to you guys about the scatter plots and the line of best fit and stuff. Okay, so here we've got a scatter plot, we've got maths marks, and then we've got something called AP maths, which is even harder than normal maths. Okay, all right, and here's the pattern of, so for example, this learner over here got about 83% for AP, for maths. All right, they got about 83%. And for AP maths, they got about 92%. That's one learner. All right. What can you tell by looking at this graph about the relationship between these two subjects? Is there a correlation? Is there a relationship? Is it a positive relationship or a negative relationship? It's positive. Learners that do well in maths do well in AP maths. Learners that do badly in maths, badly in AP maths. Okay, so it's a positive relationship. Would you say it's quite a strong relationship or quite a weak relationship? Well done. It's a strong, positive relationship. And guys, there's the 2 marks, one for strong and one for positive. Okay, right. Now, the teacher the teacher's worked out the equation of this line. The teacher knows this line is y equals whatever, whatever, right? And the teacher wants to use this line to work out the AP Maths mark for a learner who scored 30% here. Is this a reliable thing or an unreliable thing? Okay, I want you to put your hand up and I want you to tell me, why is it unreliable? Okay. There's one word I'm looking for here. That's why would it be unreliable to use a line over there?
It is unreliable because this is called extrapolation. And it's okay when you want to explain better, put the range of the.
Well done. Hello. Guys, it's what called extrapolation. Okay, this is our data over here, in between here and here. Extra, the word extra in English actually means outside. So when you say something's extraordinary, it's outside of the ordinary. Okay. All right. Now, we don't know that this line is going to carry on for other data. We haven't got data to support that. Okay. Then it says one of the students could be considered an outlier. Okay. All right. Which student is an outlier? And what an outlier means, it means someone that doesn't really fit in with the rest of the data set. Which point is an outlier? The 90, 50. So this person is an outlier. They do very well on maths, but they don't do that well on AP maths. Okay. All right. So it says circle this data point, and we've circled it. Okay. Now, I'm going to talk to you a little bit about correlation coefficients and least squares regression lines. Okay. And I want to start off with this sketch over here. All right. This is how a least squares regression line actually works, right? So we've got our line here. And what we calculate for each point, we calculate the area of all the squares. So when you look at this point over here, this is how far it is away from the line. The reason we square the numbers is because this one is below and this one's above. It's a little bit like our standard deviation. If I add up the area of all these squares, guys, just listen carefully, then that's the value. So at the moment, these squares add up to 15. If I go and change the gradient of the line, you'll see that's much worse. Okay, so if it's, I'm going to put it back to kind of there, all right, and maybe I'm going to pick this up. Now notice, do you see what's happening to that red line? The red line's coming down. This is a better line of best fit than before. We actually we can use our calculator to calculate the best fit line. And there's the best fit line. So I actually need to make my gradient a little bit smaller. Okay. And I also need to make my y-intercept a little bit bigger. All right. And you can see that as I do that, that red line is coming down, down, down. That line there is the best fit line. It's the line which gives us the least squares. Okay, now I want to show you another picture. And this picture, we are going to be predicting the correlation coefficient. Now, look at those dots over there. I want you to tell me, are those dots strongly correlated? Are those points strongly correlated or weakly correlated? strongly. Are they negatively correlated? So as the one thing gets bigger, the other one gets smaller, or they're positively correlated, so they both get bigger? Well done, they're negatively correlated. Anybody want to shout out even just a guess here for what would the correlation coefficient be here? Okay, I'm going to ask for a microphone actually. Put your hand up if you think you know. We're not expecting you to get this exactly right. I just want you to guess the correlation coefficient. Okay, all right. Salvon, what are you thinking? Okay, I like your answer. I like the fact that your answer is negative. I like the fact that you're saying 0.9. Let's see. And guys, don't feel bad if you got this wrong, okay? Because I don't know if it's negative 0.8. If you said to me, Paul, it's 0.4, I know you're wrong because I know it's negative. Okay. If you said to me, Paul, it's negative 0.1, I would say you're wrong because it's not strong enough. Okay. Hala. Okay, so now this one here, okay, I want someone to guess the correlation here, all right? And you need to try and look, is there any pattern? Are these dots maybe going kind of uphill, or they're more generally going downhill, or is there no pattern at all? I want someone to guess the correlation here. So it might be 0. Let's try 0. Hala, it's actually very 0. Okay? It's not 0. Right. Okay, let's do 2 more. Okay, this one here. In fact, you guys, I'm going to do a new sample. I want some more obvious ones here. Okay, I'm going to do another one. Okay. Oh man. Okay. Yeah, no, okay, let's do this one. Let's do this one. Okay. Guys, remember, the closer it is to 1 and -1, the stronger the correlation. Someone. Excellent. And what's your answer? 0.9. 0.9. Okay, let's see. Okay, guys, it's close. It's even better. It's 0.94. Okay, right. And we can also show, guys, we can show the line of best fit. All right, let's do another one. Let's get this one. Zero, you're going for 0. I think maybe I'm maybe going 0.2, but let's see. Okay, it's 0.24. Okay. All right, let's do one. Last one. All right, and guys, I think, well, let's see what people say here. Okay, I like your answer. I really like your answer. I would have actually gone with that as well. I might have gone with 0.4, negative 0.4. Okay, and we would both. Okay, so well done. We actually were both wrong. It's a bit stronger than we thought. Okay, right now, guys, I want to show you another thing here. All right, which is going to help your understanding of this. Okay, and that is this sketch over here. All right, so if I show the line of best fit and I'm using all of these points, that's where the line of best fit is. I want you to look at the gradient of that line. Anybody want to predict the correlation if I use all the points? So in other words, this line of best fit is using that red point. Okay. Anyone? Let's have a guess here. What might people say? Now, just be careful because although the blue ones look really nice, the red one is actually spoiling it. Am I right? Okay. So, who can tell me what will the correlation coefficient be? All right, if I use all those points, just a guess, and it's hard to guess, but anyone want to guess? Put your hand up. Okay, I want to answer this quickly, guys. So I'm going to give an answer. I'm thinking maybe about 0.6. Okay, I might be wrong by 4. Let's have a look. Okay, it's 0.88. I am wrong by 4. Okay, all right. It's actually quite strong. Now, what I want to ask you, if we don't include that outlier, if we take the outlier out, what will happen? Which is the outlier? The red one. If we exclude the outlier, what will happen to the correlation, do you think? Do you think it will get stronger or weaker? Well done. It will get stronger, guys. It's actually 0.95 if we exclude the outlier. Now, what do you think will happen to that red line if I exclude the outlier? Will it slope more uphill or less uphill? Well done. It will slope less uphill. The line of best fit without that outlier point is there. Okay, right. We might do another one of each of these just now, guys, because I would like our visitors to see this. But let's answer this question now. If we remove the outlier, so we keep at this point, what will happen to the correlation coefficient here? Will it get closer to 1 or will it get further from 1? It will get closer to 1. It will increase. It will get closer to 1. What will happen to the gradient of this line, this least squares regression line, if we take that point out? Will it slope more uphill or less uphill? Guys, that point, if you think about that point's almost pulling the data set down. The line will slope more uphill. Okay, the gradient will increase. Okay, right now, that is everything there, guys. Welcome to these learners who are just arriving now. I'm sorry that your transport was a problem. I don't know if you guys were late or if the bus was late. I'm not even going to worry about that for now. Okay, all right. We're now going to talk a little bit about analytical geometry. Okay, and again, I want to just start off just with a sketch or two just to kind of warm us up. All right, so there we've got 2 points, a green point and a blue point. Who can just quickly put their hand up and tell Ruth, what's the coordinates of this green point over here? What's its name? And this is really easy, guys. If you can't answer this question, then I'm thinking maybe you shouldn't write the exam on Friday. Okay, right, what's the answer? Well done, -1, -2. Okay, cool. What about the blue point, someone? -6, -3. Well done. Okay, -6, -3. Okay, right. So now, guys, there are a few concepts here which we want to make sure we've got properly sorted out. The first one is gradient. Gradient is how much the graph is going up divided by how much it's going across. So I've moved that point to there and that point to there. Can anyone tell me, and I'm going to put their names on, can anyone tell me what would the gradient of that line joining them be? So in other words, that dashed line, what would its gradient be? Right? And I'm hoping you don't have to use a formula here. I'm hoping you can just look and count squares. How much has it risen and how much has it run across? What is its gradient? Okay, I want Ruth to be running, guys. I want Ruth to be running all day from the top to the bottom. Yeah. 0.5. Well done. Guys, it's going to be 2/4. That's how much it's risen as we move from the left-hand point to the right-hand point, and that's how much it's run. The gradient, there it is, will be 0.5. Okay, I'm going to move these points around and I want someone else to have a go. Right. I want someone to tell me the gradient now of of this line. All right, the gradient of line AB. And I want you to think, how much has it risen? How much has it run? It's 1. It's risen 1 and it's run across 1. Okay. All right. Now, well done. I want someone to tell me about this line over here. So guys, before I do that, what gradient, what angle is that line going uphill at? If it's going at a gradient of 1, what angle is it going at? Well done, it's going at 45 degrees. And that's because the tan of 45 is 1. We'll look at that just now again. All right. Who can tell me the gradient of this line? No, not this line, sorry. This line. You can tell me the gradient of this line. Come guys, easy question. Well done. It's rising 2 and it's running across 3. Okay, excellent. All right, now very similar calculations involved with finding our length of a line. I want someone to tell us what's the length of this line. Okay, and I'm going to put in for you the rise and I'm going to put in for you the run. Okay, so I want someone to just tell me what will the length of that line be if we rise 4 and we're running across 3? Yeah, it'll be 5. Okay, and maybe that's one that we should know. 3, 4, 5 using Pythagoras, and there it is. It's 5. Okay, all right. So there we go. Right now, let's just do let's just think also about midpoint. Just remind ourselves about midpoint. Let's turn that off. Okay, if this point is over here and this point is over here, all right, now I want us to think about the midpoint of this line. Okay, okay, the midpoint of the line. And I want us just to think, if I want to go halfway from me to Ruth, okay, how could we find the point halfway from me to Ruth? What would we need? We need to know the distance between me and Ruth. Suppose it's 20 meters. Then what's half of 20? 10. We could either go 10 meters from me towards Ruth, or Ruth could come 10 meters towards me, okay, and we'd end up in the same point. I want us to think now about these 2 points and how we could find the midpoint. And I'm not really interested in using the formula, but we've gone up by 4 and we've gone across by 4. What is half of 4, guys? 2. If we add 2 to this x value, where do we get to? We get to -1. Also, if we subtract 2 from this x value, where do we get to? -1. We can do exactly the same with the y values, and there's our midpoint. Okay, all right. So I want, yeah, so that's cool. The last thing I want to show you just before we dive into solving some questions is just the idea of angle of inclination. Guys, angle of inclination is how much the line is sloping uphill from the horizontal. Okay, always from the horizontal. You might think of this as 3 o'clock on a clock face. Or if you do geography, maybe you're thinking of this as east. Okay, and we are always going that way. Now, I want to show you about angle of inclination. As I increase the angle of inclination, all right, I want you to see what happens. Okay, it never gets bigger than 180 degrees. Okay, I'm actually going to start from here. Okay. Notice you might say, oh, it's 180 degrees. Can we get an angle of inclination of 190 degrees? No, because it's now sloping uphill again. Okay. Now, I want you all to get your calculators out and we're going to calculate some angles of inclination. Okay. So just make sure you've got a calculator at hand. Right. I want someone to tell me what is the angle of inclination of this particular line. Okay. And you should be able to see it just by looking. So just put your hand up. Ruth will come to you. I think you can see it by looking just at the picture. Yeah, we've got some answers up there. 45 degrees. Hala. Does it matter where the horizontal line is? No, it doesn't matter where the horizontal line is because all of these angles are, what do we call these angles that are in the same position? If we have another angle here, let's call it. Come guys. What angle, what's this angle? They're all in the same corresponding position. Okay, right. So that was a really easy one. Let's now get someone to work out for us what will the angle of inclination be now. Okay, and I want you to tell me I want you to tell us what you did to find out the angle of inclination for this particular line. Okay. Remember, our angle of inclination is inside here. Anybody, put your hand here around the back of her fist. Okay, make Ruth run, guys. She needs the exercise. She can just run. She'd have to run past our visitors then. All right. Okay. What are you? The gradient, okay. What did you get for the gradient? 2/3. Hello, guys, it's actually going up 2 and it's running across 3. That's 0.67. Okay. Then what did you do? So tan theta is equal to gradient. So what did you get for theta? Okay, there it is. 30. Sorry. So my computer's down. Okay, there's the angle of inclination. 33.69. Well done. Okay. Right. Okay, this time I'm going to go the opposite way, all right? I'm going to ask someone, I'm going to turn off the name of this point, okay? And I'm going to turn off the name of this point. So now we don't know the points, okay? But what I'm going to ask someone to tell me now, what's the gradient of this line if the angle of inclination is 68.2? What is this line's gradient? How will I work that out? Someone just put your hand up. Ruth can run. And what did you get for the gradient? Okay, there it is. It's 2.5. Okay. As it moves across 1, it rises 2.5. Gradient 2.5. Okay. Now, I want someone else to do one for me. Let's get the gradient of this line. Okay. And guys, has this line got a positive or a negative gradient? Negative. Okay. It's got an angle of inclination of 139.4. Who can tell me what is its gradient? What is its gradient going to be? It's not difficult. Okay, it's a really easy question, I think. Yeah, what did you get? Negative 0.86, and you're 100% correct. Okay, now, maybe slightly harder is for us to do this, okay? I'm going to show the name of this point again. All right, and I'm going to show the name of this point again. And I'm going to put this line over here. And I'm going to put it over here. And again, I want to show you it doesn't matter where this goes. All right. What I want now is what's my angle of inclination now? And so I'm talking about, remember where the angle of inclination is? It's from here round to there. Okay, I want someone to tell me not only what the angle of inclination is, but what did you do on your calculator to get it? Yeah, right at the back. Oh, sorry. Morning. Okay, what did you get for the gradient? -3, okay. All right, there it is. It's actually -3. Well, that, yeah. Well, that's a tan theta is -3, yeah. And then what?
So I'm going -17.
-7. One's -70. Okay, let's just go with -71.6, okay? Okay. What did you get as your final answer? What's 180 minus 71.6?
So the answer is 108.4.
108.4. Let's check. 108.4 degrees. Let's check. Well done. Okay. What I prefer to do, and we'll get to this when we do some trigonometry just now, but what I prefer to do is I prefer to just get what we call a reference angle or a key angle. So what we would do is we would get our key. You know what a key does? It enables you to get into a different room. Okay. So if we use our key, we don't put in the negative. So we just say our key angle, we're going to undo tan of +3. And that gives us 71.6. This angle is not 71.6. This is an obtuse angle. Which quadrant is it in? Quadrant 1, quadrant 2, quadrant 3, or quadrant 4? It's in quadrant 2. Okay, and we get into quadrant 2 by going 180 minus our key angle, and that's how we get to that answer. Okay, right, guys, I want you guys to try this question. We're on page 4, okay, and then I'm going to take some answers. So basically, I'm sorry that the page layout on this document is kind of a bit pear-shaped, but all right, okay. All right, we'll take answers as and when you're ready. I see quite a lot of you. Okay, lots of people in the back wanting to answer questions there. First, yeah. All right. The gradient of AB. Okay, what's the gradient of AB? Negative 1/2. Yeah, it's negative 1/2, guys. Remember, I actually like to say, how much have we risen? Well, we've actually dropped down by -4. And how much have we run across? We've run across by 8. -4/8, -0.5. Okay, I like that. Right, next. What did you do next? Yeah, so you've worked out this gradient here so far. Well done. Gradient of BC, yeah. It's 2. Okay. So the gradient of BC is 2. So now what? Yeah. Well done. La la. Okay. Okay, all right. So we just need a reason here. The reason is that the gradient of AB times the gradient of BC is -1. Okay. Can anybody tell me, is there another way that we could prove a right angle here without using gradients? Is there another way? Yes, up at the back, yeah. Yes, I've seen online from Jimmy has given us an answer. Let's see what our in-person audience says as well.
I use the distance formula first.
Yes. So you worked out the distances, and we're not going to do the whole thing, but then what did you do?
The distance of AB is 4.
Yeah.
The distance of AC is 10 root 5.
Of AB, sorry. It's 10 root 5, sorry. Yeah.
AC is 10.
AC is 10. Just 10. Okay.
AB is 4 root 5.
Yes.
And BC is 2 root 5.
Okay, well done. And then what did you do?
And then I apply cosine rule.
Okay, you applied the cosine rule. Okay, that's cool. All right, perfect. Yes, 100%. And I'm not going to ask you to carry on with that, but you get that this is a 90-degree angle. Okay. Now, Jimmy, who's online, actually said we could use the converse of which theorem? Guys, from what does Pythagoras' theorem says? It says if there's a 90-degree angle, then this one squared plus this one squared is that one squared. What Jimmy says is if you show that this squared equals that squared plus that squared, then you have proved the 90-degree angle, converse of Pythagoras. Okay, so we've actually got kind of 3 different methods. The cosine rule proof actually does come from Pythagoras as well. So it's sort of like 2 methods, but yeah. Okay, now it says that this is a right angle triangle, and someone's done us a whole lot of work for us, because now we must to find the area of this triangle. Yes, let's have someone.
Of BC.
Okay, so someone's done that for us. Did you get the same answer? Yes, okay, great. So you calculated the distance BC, and then how did you get the area after that? Okay, half the base times the height. Okay. So what's it going to be? Half times 2 root 5 times 4 root 5. Okay. And I want to know, and I want you to be very honest with me here. I want you to tell me your final answer, and then I'm going to ask you something else. Yeah. 20 units squared. I want you to tell me honestly, did you use a calculator to work this out? You did? Oh, no, highball. Okay. All right, guys. You should be able to work this out in your head. What's the square root of 5 times the square root of 5? 5. Yeah. What's 5 times 4 times 2? It's 40. Divided or times by half is 20. Okay, well done. All right. Guys, remember what I've said to you. Your brain is like a muscle. If you go to gym and you pump iron, what happens to your arm? It gets stronger. If you use your brain, it gets stronger. All right. Let's look. I have seen a question online, someone asking me. I'm seeing lots of participation online. That's great. Someone asked me to confirm about the angle of inclination. I'm going to come back to that question because we're going to encounter another one. We want the midpoint of this line. You can tell us the midpoint of AC. Sorry, BC. Yeah, don't do that, guys. Make sure you find the midpoint of the correct line. So I'm looking, it looks to be somewhere over here. Yeah. Yeah. And what did you get? You got 3. There 2. Well done. Okay. Now, you've used a formula there, okay? And I'm not unhappy with the formula, but I'm hoping, because what happens if we get this question in an exam? And we might get this question next Monday. That's like 9 days away, all right? And what it asks us to do, this question says, don't find the midpoint, but in fact, find the point that is, find the point that's 1/3. All right. So if this is like P, this is 2P. We are 1/3 of the way along the line. Now, I want us to think about how I explained midpoint earlier. I said, if I want the midpoint between me and Ruth, I need to know how far the distance is, and then I'm going to go half that distance. Who can explain to me, how will I find this point? Okay, because this can be asked. Have you got a formula on your formula sheet for 1/3? No. Or 1/5 or 1/4? No. Right. I want someone to explain to me, and I want us to look at the distance. Sorry, I'm going to change up this number here, guys. I did this in my head, and I'm going to make that slightly more friendly. I'm going to make that 4. Okay. How much have we run across from this point to this point? 6. What is 1/3 of 6? 1/3 of 6 is 2. So we are going to add 2. All right. How much have we risen from this yellow point, the left-hand point? And remember, when we're talking about rise, it's not yellow, as it's turned out, it's pink. We talk about rise. How much have we risen? We've risen 12. What's 1/3 of 12? It's 4. All right. And if I add 4 to 4, what do I get? 8. Guys, this is the point that is 1/3 of the way along the line. Does it make sense? No. Okay, I think it makes sense, guys. If I want to be 1/3 of the way between my hands, if I know the distance, I must just find 1/3 of that distance and then add it to that. And I've done that with the X's and I've done it with the Y's. Okay, right, let's move on. Let's see what the next question is on our workbook. Okay, so it says find point D if ABCD is going to be a parallelogram. So ABCD, guys, I think D is going to be, yeah, I don't know where it's going to be. It's going to be like somewhere over here, maybe. Okay, I don't know, somewhere here, maybe. Who can tell us how are we going to find point D? Yeah, I'm ready. The 2 ways, okay? Yeah.
AC.
Okay, the midpoint of AC. Right, what did you get for the midpoint of AC?
Oh.
No, careful. 4 and minus 4. Halfway between 4 and minus 4. The midpoint of AC. Your -2 is correct. What's halfway between this point and this point? 4 and -4.
0.
0. You're absolutely right. This here is the midpoint. It's -2, 0. Okay. Right. Now what are you going to do?
the midpoint of A equals to the midpoint of B.
Well done. Okay, so the diagonals, all right, the diagonals of a rectangle or a parallelogram, they bisect one another. Sure what that is. Okay. Okay. Right. So okay. So guys, yeah, Sam, huh? Yeah. Okay. Where you going? Okay. Okay. All right. So we've got a learner who's Uyagula. She's sick. Okay. All right. Let's carry on, guys. Yeah.
And if that's the concept, so it's
Yes, so the x values, so if we let this x value, I'm just going to call it x. Okay, so x plus 4 over 2 must be what? Well done, okay. So x plus 4 must equal -4. Yeah, okay, well done. -8, well done, okay. X equals -8, okay. -8, well done, hala. All right, and what's the y value? The y value is 0 because obviously halfway between 0 and 0 is still 0, okay. Well done. All right, and you said you had two methods. What's your other method? Okay, if you don't mind, I'm gonna show you my other method, okay? Guys, because this thing is a rectangle, when we move from this point, to that point, because it's a rectangle, the opposite sides are not only equal, but they are also parallel. Now, in science, those of you that do science will know about vectors, okay? But do you agree, guys? Just listen carefully to this. When I go from point B to C, what happens to my x and y is exactly what must happen when I go from A to D. Okay? So, in words, when I go from B to C, what happens to my x value? Does it get bigger or smaller when I go from B to C? It gets smaller by how much? By 2, okay? So, if it gets smaller by 2, then this x value must also get smaller by 2. And now I'm not so sure about this answer that you gave us here. All right. Because here you said x plus 4 over 2 must be -2. Oh, goodness, x. Yeah, this has got smaller by 2. This was got smaller by 2. I'm getting a different answer with our two different methods, which is a little bit of a problem. Okay. I'm just trying to see where I've made a silly mistake here. Oh. Yes. -10. Thank you. Okay. -10. Okay. Oh, this original midpoint. Yes, the original midpoint is -10. So then this should be -1. This should be -2. This should be -6. Okay, now guys, look what I was doing here. Sorry. The x value is getting smaller by 2 when we move down this blue line. So this x value must get smaller by 2. -4 getting smaller by 2, -6. What's happening to my y value when I go from here to here? It's getting smaller by how much? 4. So this y value must get smaller by 4 as well. All right. And so we can get the answer just by inspection. Okay. The midpoint idea is a very nice idea as well. All right. Then it says, what's the equation of AB? The equation of this line over here. Yes, we've got some answers. Thanks to all those learners who went to help the other learner. I hope everything is okay there. All right. I think she's gone to the sanatorium, I'm hoping. Okay. Yes. Well done, the grade. AB is -1/2. And then, yeah. Okay, so you use y equals mx plus c. At which point did you use A or B? A. Okay, so y equals mx plus c. And then you substituted in the point, you substituted in your gradient. And A is, you use point A. So what did you get for the y value? 4. Is everything okay? Oh, is it the same thing? And the x value? -4. Okay. So now we've got an equation here. All right. And what did you get for C? C is 2. Okay. So C equals 2. And our final answer, y equals -1/2 x plus 2. Okay. Right. Well done. Okay, let's just look at the diagram. Does it look about right? Guys, to me, it looks about right because you're saying that the y-intercept would be 2, and that looks about right. Okay, all right. Then, give the equation of the circle with the center 5, 0, and the y-axis is a tangent. So I want someone to tell me how to do this. 5, 0 is over here, guys. And I want the y-axis to be a tangent. So I'm looking for a circle like that. Okay, I'm going to just move this circle a bit. Yeah, we've got some answers, folks, down here in the front row. What's the equation of this circle?
The equation will be x minus 5.
X minus?
X minus 5.
Yes.
Whole square.
Yes.
Plus x squared
Yes.
equals to
Equals to?
25.
Well done, 25, 100%. Okay, I've written the y minus 0 here, just to remind all the learners that that's our formula for a circle. Okay, so you just said y squared, and y squared is 100% correct. Okay, right. So now we're getting into a little bit of trigonometry. Before we dive into this, guys, I want to just quickly give you a quick reminder of our trig graphs, right? And this diagram here, which we know tells us in which quadrants each ratio is positive. All, sine, tan, cos. So if I had to say to you, draw me a cos graph, okay, I'm going to use this diagram to help me draw a cos graph. And I'm going to show you how I'm going to do this. This here is 90 degrees. This here is 180 degrees. This here is 270 degrees. And then lastly, over here, 360 degrees. Right. Guys, is cos positive or negative in this first quadrant? It's positive. And we know that the cos graph goes like that. Is cos positive or negative in the second quadrant? It's negative. This is quadrant 2. Is cos positive or negative in the third quadrant? Negative. Is cos positive or negative in the fourth quadrant? It's positive. Okay, so that's the basic shape of our cos graph. We need to know those, right? We need to know the basic shape of a cos graph, a sine graph, and a tan graph. We're going to quickly remind ourselves of the transformations of those graphs, okay? And I'm just trying to find the right sketch here. Okay, there it is. Okay, I'm going to show, this time I'm going to show a sine graph, right? And the sine graph that I'm going to show, so my computer's just trying to wake up, is just a vanilla sine graph, okay? Vanilla hasn't been moved, hasn't been shifted. Okay, it's positive in quadrant 1, it's positive in quadrant 2. Now, what will happen, guys, if I add a number at the back here? In other words, if I draw a sine of x plus 1, what will happen to the graph? It will shift up by 1. Have a look at this. The graph shifts up by 1. There is sine of x plus 1. All right. What will happen if I add 20 degrees inside here? So I find the sine of x plus 20. I want someone to put their hand up, right, and tell us the sine of x plus 20. Yeah, well, someone. What's going to happen to this graph if I add 20 to the x value? Yes, you have a question? Good. Oh, did I? Thank you very much. Okay, I always love to hear I've made mistakes. Not that I love to hear that I've made a mistake, but I love to hear that we can fix the mistake. Yeah. So which question was it? Which question? On the coordinates of D. Over here. Yeah, thank you. I think I have made a mistake. What should it be? It should be 0. Sorry, guys. Thank you very much. Okay. It should be 0. All right. We are dropping down by 4. So we're dropping from 4 down by 4. Thank you very much. Okay. I appreciate that. All right. We were looking, guys, we're looking here. I'm now looking for someone to tell me what will happen to this green graph if I add 20 degrees here where it says plus 0. If I draw the sine, here we go first, front row. Okay, or then. Okay. If we add 20. Well done. Yes. Well done. It will shift 20 degrees to the left. Okay. All right. My thing's actually not allowing me to shift it 20. That's 30 degrees. Well done. And also well done to you described as an unknown user here. All right. It's actually you also said this is someone online. Okay, what will happen, guys, if we multiply at the front here by 2? Who can tell me what will happen to the graph if we multiply by 2? So in other words, instead of sine x, we draw 2 sine x. What will be affected and what will happen to the graph? The amplitude will be 2. Can you describe in words like what will happen to the graph? Is it going to stretch or squash, or is it going to stretch vertically? Well done. Okay, guys, have a look at this. If the amplitude is 2, the graph just goes up to 2. While you've got the microphone, keep the microphone, my friend. What if instead of 2, we had -2? No, squished, no. It won't be squashed. If it's -2, guys, I want you to think about 2 sine x. If we now put a minus in front, what's it going to do to the graph? Well done. It will actually reflect it. So it's going to stretch it and then reflect it. Okay, right. Okay, and then the last one. What happens if we, instead of having a sine of x, what if I make this a 3 here? Sine of 3x. Sine of 3x. Anyone want to tell me what will happen if we go sine of 3x? What will be affected? The period. Will the period get bigger or smaller? What will the period become? 120 degrees. Well done. What will happen if I make this 3? We will get 3 times more graphs than usual. All right. And what I want you to see, sorry, that's not 3, that's 3 now. So that's 3. Our period, we get 3 graphs in 360 degrees. So our period is now 120 degrees. Okay, let's answer this question now that we've reminded ourselves about how graphs work. Okay, I'm looking for the equations of each of these graphs. Yes. You can just answer for F, please. Yes. Yes.
So we have the graph shifted 45 degrees to the right. So we have 2 cos into x minus 45.
Wow. Okay. Well done. That sounds very good. Okay. This. Okay, guys. So f of theta is 2 cos theta. Okay, I've used x on the axis here. I should have used x, but anyway, 2 cos of theta minus 45 degrees. Let's just look at this. The 2 is definitely correct, and the graph has moved 45 degrees to the right. Allah. Okay, let's get an answer for g of theta. What does g look like? Okay, is it a cos graph, tan graph, sine graph? What's been affected? Yeah. One of the things I'm going to look at is the total height of the graph is, what's the total height of this graph? The total height of this graph. It's, guys, it's 2. Okay, so has it been stretched, or is 2 normal for this graph? 2 is normal for this graph. Okay, who can tell us what's happened to this graph?
So first we have a sine graph.
A sine graph. Well done. To me, it looks like a sine graph. Well done.
And the amplitude hasn't been changed.
The amplitude hasn't been changed. Well done. So it's sine of something. Yeah. We've got 1, 2 graphs. Yes. Well done. It'll be 2x or 2 theta. Yes.
And the graph downwards 2 units per population. 1 unit per population.
Well done. So final answer. Well done. All right, excellent. Guys, that's just a sine graph. The sine graph whose period has changed and it's been dropped down by 1. Okay. All right, now we're getting into these questions. I like these questions. Okay. Well done. We've got some hands up. All right. And remember this little diagram, we're going to use this little diagram. We might use another diagram too. Yes, hi. No, you don't have to show the diagram. You can just tell me what you can do. Tell me what you think the answer is to this one. And how did you do it? Well done. 360 minus 18. And then what is the answer to that reduction formula of cosine 360 minus 18?
It was G over 1.
Yeah. So well done. It's going to be, guys, sorry, I didn't want to highlight that. This question is about 18 degrees. So this learner has found 18, all right? Which quadrant are we in here? We're in quadrant 4, that's fine. We're in quadrant 4. And so this is going to be exactly the same as the cos of 18. And as you said, that is just going to be the same as, not G degrees, just the same as G. Okay. All right. Okay. Sine of minus 108. You can tell us. Yeah, we got some hands up. Sine of minus 108.
Minus 5, which we don't need to minus 7.
Okay. Yeah, I'm not. Yeah, I'm just not sure how to explain that. I think it might be right. I'm not sure how to explain that to the learners here in the room. Which quadrant are we in? No, at minus 108. We're actually in quadrant 3. Okay. Yeah. I'm going to, guys, does anyone remember there's a little trick? If we're not sure which angle we're dealing with, and I think you probably know how to do the question. Sorry, I'm not sure. Yeah. Maybe carry on. Let me let you carry on. Okay, carry on. Just. 180 minus 72. Okay. Yeah, this is all good. This is all good. Okay. Yes. Yeah. Why are you going to G now? Just help the learners understand what is sine of 72 the same as? It's coming off a vertical axis. It's the same as the sine of 90 minus, this question's all about 18. What's the sine of 90 minus, what's 90 minus, 72 is 90 minus 18. What's the sine of 90 minus 18? Cos of 18. And then you said, and you're absolutely correct, our final answer is negative G. Okay. Right. Okay, guys, for me, this might have been a bit simpler, okay? If we had, look where the angle is. Guys, if this is 108, all right, and we're coming around this way, this piece here, okay, guys, just let's keep focus. This piece here is 90 degrees, okay? So this piece here must be 18 degrees, okay? All right, and now are we 18 degrees away from a horizontal axis or a vertical axis? Vertical, and when we come off a vertical axis, we change to our co-ratio. Okay, who can help us with cos of 144 degrees? Hi.
180 minus
Well done.
of 80.
Yes, okay, so 36, good. 36 is significant because it's twice 18, it's double 18, yeah?
Then negative 2 cos
Okay, I want you to go slightly slower for the rest of the learners. What does cos of 180 minus 36 reduce to? Well done. Okay, that's going to make it a bit easier for people to understand what you're doing next. Okay, and then?
square 8.
Okay, so negative. Do you have brackets or not? Okay, okay. Cos of 2 lots of 18, guys. Remember, we've got 3 different formulas for cos of 2 theta. Okay, we're going to use the one that only involves cos, and that's 2 cos squared 18 minus 1. Okay, and so your final answer, what's your final answer?
Negative 2 g squared. Oh,
Well done. Hala. Negative 2g squared plus 1. Okay, excellent. Right, tan of 198. Okay. So tan of 180 plus 18, yes. The positive or negative in quadrant 3? Positive. Well done. And then what did you do?
Square root of 1 minus its square.
Okay, I think maybe a lot of learners might not know how you got there. Okay, I'm going to suggest that we draw a diagram now. Okay, and our diagram is going to look something like this. Okay, this is 18 degrees. Cos of 18 is 1. No, sorry, cos of 18 is G. Cos of 18 is G. What must I put over here? This must be G. And what must I put over here? 1. And this must be square root 1 minus G squared. Okay, and so carry on with your final answer, which was sounding good. Well done. Okay. Right. Area. Hi.
Okay, for this question, I use the sine rule.
Okay.
So I have to find the sine AC.
Hey, so you're trying to find this side over here. Okay.
So I say sine of angle B over AC is equal to sine of 20 degrees over 70.
Okay.
And then I cross multiply the
Yes.
AC is equal to 40,968 centimeters.
Okay, I'm going to just write down that if we cross multiply, we get 7 sine 133, and we get AC times the sine of 20. So on this side, we've got AC times the sine of 20, and then we divide both sides by the sine of 20. Give me, sorry, like that. Give me your final answer you gave me just now.
14,968 centimeters.
Okay, 14,968, that's quite exact. Okay, it's a good idea, guys, to keep that number in your calculator exactly. And you remember how to do that. I've shown you before. I'm going to just quickly do this. 7 sine 33. I'll make sine 133. I'll make this calculator a little bit bigger. It's very small. Okay. Over the sine of 20. Okay. And there it is. What I'm going to do, I'm going to go shift store A. And what that will do is it will remember that number. If I need that number back, I just go recall A. Okay. All right. And when I do that, guys, when I do that in a test or an exam, I do that for myself. That's just reminding me I've got that number exactly in A. Okay. Now, what did you do next? Okay, you can use the area formula. You're missing an angle though.
So angle is.
Okay, and that's just angles of triangle. That's 153 degrees. You're absolutely right. This is 27 degrees. Okay, and then what did you tell us how you use the area formula?
Area of ABC is
Yeah.
equal to 1/2 A.
Yeah. Okay, I'm not going to write the formula down. I'm just going to 7. Yeah. Okay. All right. And your final answer?
8 centimeters squared.
23.78 centimeters. And I'm very proud of you for remembering centimeters squared. Well done. Okay. All right. So, question D. This is a trig equation. It's looking quite complicated, but maybe not too bad. Guys, before we answer this question, just listen carefully to this, guys. Listen carefully. What does this do? What does this do to the graph? I want you to show me with your hands. What does that 2 do to that graph? I'm seeing someone going like this. It's going to squash it. Will we get more solutions or fewer solutions than normal with this 2 here? Guys, I'm going to go back to my sketch here. Have a look at the purple graph. If I put a value in at -0.5, how often does the purple graph hit that orange line? Answer this question, guys. How often does the purple graph hit the orange line? Twice. Now, if instead of the purple graph, we have sine 2 theta, how often does it hit the orange line? 4 times. We're going to get twice as many solutions as usual. Normally, we get 2 solutions in 360 degrees. Before anybody even answers this question, I'm telling you that I'm expecting 4 answers. All right. Tell me what they are. How am I going to find them? Someone. Yeah. Yeah.
Sine 2 theta also negative sine into 8 because I checked.
Okay. So negative sine 30. Okay. Yeah, I'm going to do it slightly differently, but yeah, you've got 30 degrees. Okay. Then what did you do?
I said 2 theta.
Okay, so you said negative sine 30. Okay, I'll do it your way. I'm a little bit worried that it might confuse learners, but let's try. Let's see. Yeah. Okay.
I said 2 theta plus 30 equals to
Negative 30.
Yes.
So now you've taken this negative inside now. Yeah. So, okay. All right. So, guys, I'm going to Can you give me your final answers? Did you get your final answers or not?
Is equal to 1 plus 3 times 1 times okay, element of the number.
Okay, we don't want a general solution. We want 4 answers here. Okay, guys, I'm going to just quickly explain what I think is the clearest way of understanding this. Okay, so what we're going to do, we're going to find a key angle, key here. Right, we are not going to put the negative into our calculator. We're going to undo sine of positive a half, and we get 30 degrees. Okay, then we say to ourselves, which quadrants do we want to be in if sine is negative? We want to be in this one and this one, number 3 and number 4. How do we get into quadrant 3 with our key? The key gets us into a room. How do we get into room number 3? 180 plus 30. 180 plus 30. And how do we get into quadrant 4? 360 minus 30. All right, now we can add 360k to both of these. And now, only now do we say, this isn't theta. This is 2 theta plus 10. Okay, and now this is what we've got to solve. And from here, it's just algebra. All right? Okay, so we're going to get 210 minus the 10. Okay, so we're going to get 200, and then we're going to divide by 2. So theta is going to be 100 plus 180k. Norma, here we've got 330. We minus 10, we get 320. We divide by 2, we get 160.
Yes.
Okay, did you get these? Well done. All right. Now, what I did, I asked you, you gave me some Ks. I want our actual answers. And remember, I said I'm expecting 4 answers. Okay, so if K is 0, I get 100 degrees. If K is 1, I get 280 degrees. That's thinking I can't have 280 degrees. Can K be negative 1? Guys, if K is negative 1, what answer do I get? 100 minus 180? Negative 80. All right. If I subtract another 180, I go outside of here. Here, K is 1. If K is 0, I get from this one, I get 160. And if K is minus 1, I get minus 20. And those are the only 4 answers. Which angle is 90 degrees? BCD. Guys, BCD is 90 degrees. Why? Angle in a semicircle. Okay, hold on. BCD equals 90 degrees. Angle in semicircle. Nice. Okay. Angle in semicircle. Sorry. All right. Then they ask us to find angle A1. Now, I'm going to draw this. I'm going to write my solution here so we can still see the diagram. Angle A1. Okay. I want you to give me all the reasons and I want you to try and explain it fully. So for a learner who's not sure, you are right. Angle A1 is 38 degrees. Guys, this question, just to have a look, this question's 2 marks. If you just say A1 is 38 degrees, 1 mark only, okay? I want you to explain why. Okay? Yeah, so let's start at the beginning, okay? Let's start right at the beginning. OA equals OB. You're telling your friend, OA equals OB, and your friend says Y, and you say radii. Okay, and then you say, this angle's 38 degrees, and your friend says Y, and guys, it's angles opposite equal sides. That's the reason. Okay. We know that this side and this side are equal. So the angles opposite them are equal. So this is 38 degrees. Okay. Next question. And guys, one of the things I've spoken to you about this before, when I look at this diagram, what's special in this diagram that we haven't used yet? Just shout it out, all of you. We haven't used this line here yet. Huh? What sort of line is it? Tangent. Okay, let's see what's coming next. Angle O2. Well done. Angle O2 will equal 2 times B1. All right. Why? Angle at center. All right. Can anyone, and so what's the answer? 100%. I nearly wrote 76%. 76 degrees. Can anyone tell me another reason why O2 is 76 degrees? You can just shout it out for me. It's an exterior angle of a triangle. Well done. Okay. Guys, I want to quickly show you this sketch. All right. And it's a really important sketch because there are so many different flavors of the angle at the center. Okay. Yeah. So we've had a learner online asking about isosceles triangle. I know that some of the exam bodies don't accept isosceles triangle, and I'm looking to Ma'am Nele. I think she's out the room. No, she's there. Can they say isosceles triangle, or must they say angles opposite equal sides? No, guys, you cannot use isosceles triangle anymore. We used to accept isosceles triangle, we don't anymore. Just have a look at this sketch. This sketch is our angle at center. There are 4 different flavors of this sketch. Have a look here. If this point drags around to there, and that is the one that the learners just helped us with now, okay? Do you see that this angle, the blue angle's at the center, the red angle's at the edge? Now, if I drag it around to here, the blue angle's still at the center, the red angle's at the edge. Is this the angles in same segment theorem? No, this is angle at center theorem. This is not the butterfly Venn. This is not Venn theorem, okay? So we've got 3 flavors so far, all right? And the 4th one is very strange. Is this a cyclic quad? No, this isn't a cyclic quad. But this angle over here, it's now a reflex angle, is still twice that angle over there. Okay, notice if I move this angle around, it doesn't change size because it's got to be half of that angle. Okay, very nice. Then we are moving on to angle C4. Yeah, let's get an answer for C4. Now C4, and remember, I said to you just now, there's a line we haven't used yet. Yeah, what's C4 going to be? Morning. How much? 33 degrees. Why? Well done. Tan good. Excellent. Okay, well done. Right. Okay. All right. Enduna Ikasi. Now, guys, my favorite questions. These ones are my very favorite questions in geometry. Okay. Let's see what we can do here. Yeah. Hi.
E over AC is equal to BF of FC.
Okay, equals BF as to FC. Now, guys, sometimes we write the ratios like this, and you said to me AD over DC is AD over DC is BF over FC, and that's absolutely fine as well. Okay, so, but I do need a value, and I do need an answer as well, a reason. So you said BF as to FC. Okay, your reason is prop int theorem. What else must you say? Well done. We've got to put in the parallel lines. AB parallel DF. Good. Okay, now, but I actually want the value of this. What is it in numerical terms? Well done. It's 2 as to 3. And guys, I'm going to show you a strategy here. We are going to put this information onto the diagram here. CF to FB is 3 as to 2. I'm not going to write 3 and 2 because I don't know the lengths of these lines. I'm going to go 3M and 2M. And now what the learner has told us is we've got 3 and 2. So maybe it's 3P and 2P. And so the ratio will be 2P as to 3P. And the P's will divide out. Okay, and we get 2 over 3. Okay, Allah. Right. Now, this is where it gets a little bit more interesting. We want the area of triangle AFD. Now, triangle AFD is this little green triangle over here. And we want the ratio of that area. We want the ratio of that area to DFC. So we want the green triangle to the pink triangle. Okay, the pink triangle being this triangle over here. Now, okay, who can tell me what's the answer going to be? Morning. Okay, and the perpendicular height of both of those triangles comes somewhere here. Okay.
Over 1
DC times perpendicular height. Allah. Yeah. 2 as to 3. Okay, guys, those triangles, well done, very well done. They share a height. Okay, and I want to quickly show you this sketch because this is something that my learners, and I teach some very, very clever boys, but they find this difficult. Okay, so I want to show you a sketch I made here. Here it is. Okay. All right, look at these two triangles, the green one and the red one. Okay, do you see that? Those triangles share a height. It's not obvious that they share a height. If you turn the diagram around, it becomes obvious that they share a height. I'm going to turn the diagram around. And do you see that they share a height now? There's the height. Okay, they still share the height when we turn the diagram around. But it's not so obvious that they share a height. So in the exam, often with a geometry question, it will help you to turn the page. Often when you turn the page, you're looking at it from a slightly different angle and you're able to see things. Okay, right. So let's have a look now. The next question asks us for EF to FB. Now we want this piece to this piece. I know what FB is in terms of M, but I don't know what FE is. Who can tell me how we're going to do this? I'm going to write the answer up here at the top left, top right. Hi. EF to FC, I'm going to check this, I'm just writing down what you said. EF to FC is AD to DC. I'm agreeing with you, but I do want you to tell me why. What's the reason? What is the reason that you've gone that as to that equals that as to that? Well done. Which parallel lines did you use? DE parallel to AF. Well done. Okay, now just wait 1 second, because I want to just see if I can help some learners who can't see that, who can't see what you've done there. And the way I'm going to help those learners, guys, watch what I'm going to do. I'm going to use a white pen, and I'm actually going to take this line out. And I'm going to take this line out. Okay. Do you see the proportional intercept theorem now? It's easier to see, am I right? I'm just focusing on those lines. Okay, so I'm going to put those lines back. So what is that ratio as a number? What's the actual answer for the ratio? It's what's EF to FC going to be? EF to FC. Okay, but it's going to be 2:3. Am I right? AD to DC is 2:3. So EF is also going to be 2:3. Carry on. Sorry, if I'm writing it wrong, tell me. Yes. Okay. EF divided by 2K equals 4L. Yes. 2L divided by 5L. Okay, I'm a little bit unsure. So you said EF to FC. So where's the 2K coming from? What you did here in red, what I've written in red is perfect. 3K. 3K over here. So did you call this K? Yes, you called this K and this K. Okay, I'm changing it to your variables to try and help. And use L on the other side. Okay, just a little bit of a warning about L. Depending on how you write the L might be a bit dangerous because L can look like a 1. Okay, but I'm going to write it. I'll use L. You use L. Okay. Okay. So I'm just worried about this EF as to 3K. Then you said that is 2L as to 5L. Okay, yes, okay. Okay. Okay, so then what? Yeah. EF is 6 over 5K. The K is on the top, huh? Yeah. 6 over 5 times K, yes. All right. Or you can write it like this as well. 6 over 5 times K. All right. So EF is 6 over 5 times by K. Yeah. EF over FB is 6 over 5 K over 2K. Okay? Yes? Allah. Before you get the microphone back, I want to ask you what career you want to do. What do you want to do after school? Okay, so maybe not medicine. I've got a better IT. I've got an even better idea. I want you to become a maths teacher. Okay. Yeah, very, very nicely explained. Okay. Right. Now, guys, this question, and I want to quickly remind you, and again, I'm going to show you a sketch. Okay. I'm going to quickly show you a sketch because when we've got figures, guys, listen carefully to this. When we have got figures that are similar, all right, something interesting happens with their areas. I want you to look here. I've got a scale factor of 2. So this rectangle, the blue rectangle, the sides are half as long as the gray rectangle. But I want you to look at the areas. If the scale factor is 2, the area is 2 squared times bigger. All right. And if I make the scale factor 3, the area is 9 times bigger. This, I've drawn it here. Just listen carefully, guys. I've drawn it here with rectangles. But if I change the shape of this, do you see that the other shape changes as well? I want you to think of this as a shadow. All right. If I hold my hand up in front of the projector, I get a shadow of my hand. My actual hand and the shadow are similar. Do you agree? Okay. If I come closer, the shadow gets smaller. If I go closer to the projector, the shadow gets bigger. And it's similar every time. Okay. Now what happens is that if the sides are 2 times bigger, the area actually goes to 4 times bigger. Okay, so it squares up, and it doesn't matter what shape it is. As I said to you when I started, if I make this thing look like a rectangle, then it's quite easy to see why it's 4 times bigger. The reason it's 4 times bigger, guys, is because this rectangle will fit in here twice in that dimension. It will also fit in twice in that dimension. Do you see why it's 4 times bigger? Does it make sense? It always makes sense. Okay, right. Now, are these triangles similar? These triangles, are they similar? Yes, they're similar. Okay, and we know that area number 2 as to area number 1, all right, is 2.25. So area 2 over area 1 is 9 over 4. But remember, if we take a side 1, and look which side I've taken. I've taken the one opposite the 41 degrees. So I'm going to take this side 2, also opposite the 41 degrees. Side 1 over side 2, side 2 over side 1. That must be squared. Okay? That must be squared to give us the ratio of the areas. Listen carefully. We square the ratio of the sides to get the ratio of the areas. In this question, they told us the ratio of the areas. So now, what must I do to both sides to find the ratio of the sides? How do I get rid of this? Square root both sides. So side 2 over side 1 is going to be the square root of 9 over 4. It's going to be 3 over 2. Okay, just be careful here though, because this is asking for AN over BH. It's actually asking for the other way around. So the answer, AN over BH, we're going to turn it upside down. It's going to be 2 over 3. Okay. Right. Okay, we're going to do this question. Okay. Question 5. How do we work out the standard deviation? And this question, guys, we cannot use our calculator, okay, because of the variable involved. I'm going to write down a formula that you get given in the exam. It looks like this. It's a very nice formula. You can tell me, what does this formula tell us? Put your hand up and ask Ruth to come tell you, what does this formula give us? Anyone?
This formula gives us the variance.
Well, it gives us the variance, okay. And just keep the microphone for now, please. Okay. The reason I like this formula, okay, is the Greeks came up with lots of the mathematics. And this formula has got two sigmas in this one here is a small sigma, and it stands for standard deviation. And then this one here is a big sigma. And what does it tell us? And I'm going to ask Langa if he knows what it tells us, because last night I was chatting to him and he said, oh, I don't like this one thing in maths. Okay, what is this, Langa? Where's Langa? I'm looking for Langa. What is this symbol and what does it tell us? You told me the name. It's also a sigma, okay? What does it tell us to do? Well done. It's a Greek S for sum, okay? All right. So, guys, when I want to use this formula, what's the first thing I need to work out? I need to work out the mean, the average. Okay. What's the average of 2p, 2p, and 6p, and 10p? How many p's altogether? 20p. What's the average? 5p. Okay. Now, guys, what sigma notation says is take the first data item and minus the mean. Then take the second one. Okay, and we're looking for, guys, the reason this formula is interesting and important, we're looking for the spread of the data. So we're looking how far each one is from the mean. Now, I'm not going to write them all down, okay? But what's the last one would be 10p minus 5p. Now, if we just added these up, this one is a negative number and this one is a positive number, and they would start cancelling each other out. So what we do to prevent that is we square them. Okay, so this is going to be squared, this is going to be squared. This one's going to be exactly the same as 2p squared, so I'm just going to double this first one. What's 6p minus 5p? Just 1p. Okay, so there's my whole formula. All right. Okay, and I'm going to divide by n. Okay, and so now this is going to be, this one is negative 9p squared is 18p, 19p, and this one's 1p, so it's 20p squared. How many terms have I got? How many terms have I got? 4. So it's 20p squared over 4. It's actually 5p squared. Is that the standard deviation? Is that the standard deviation, guys? No, that's not the standard deviation. That is the variance. What do I do to variance to get the standard deviation? Square root. So my final answer is going to be the square root of 5p. Okay. Can we check this on a calculator? Yeah. If we just, for example, if we let p be 1, let's just make sure we know how to do this on a calculator. Sorry. If we let p be 1 and we go into our stat mode stat, and we put in the numbers just with p equals 1, in other words, we put in 2 and 2 and 6 and 10. All right, and now we're going to get the standard deviation. So we go shift stat, we go for option 4, that var doesn't mean variance, it means the variables about this data set, and then option 3. And our answer should be this. Okay, I've messed this up somewhere. Okay, I'm pleased we checked it, because our answer should have been about the square root of 5, which it's not. Guys, this is 9, so it's 18, 19, and this one's 25. 19 and 25 is 44. It's actually 11p squared. Okay, and sorry, it's 44p squared over 4. It's 11p squared. It's the square root of 11p. Sorry, guys. Okay, and just to go back here, if I square this number, I will get 11. Okay,
I'm sorry.
yes.
You should get the sum equals
Thank you. Are well done. Thank you. Okay. You, another person who can be a maths teacher, for sure. All right, guys, I'm being stupid here. The p is not under the square root sign anymore. It is 11p squared. So it's the square root of 11 times p. Okay. All right. Now, I want someone to explain what's happened here. Every term has, we've just added p to every term. Can anyone tell me, and I just want you to think about what standard deviation tells us. It tells us about how spread out the data is. If we've got a data set and we add 1 to every number, does the spread change? Okay, guys, just think about this. So every one of our numbers here, we've actually added p from the original data set. Okay, so we've added a p to all of them. What will happen to the mean? What do you think the average will now become? It will become 6p. Okay, you can check that. That's 3 and 3 is 6, 13, 24. The new mean is 6p. But I want you to look at the gap here, guys. Look at this gap for the first one now, 3p minus 6p. That's the very first term. Is this gap different or the same? Is the gap different or is it the same? It's exactly the same because the terms have got bigger, but the mean has also got bigger. So an important piece of understanding here, if you add a number to every item in a data set, the standard deviation will not change. The answer here will be the square root of 11p again. All right, and that's because the spread is not changing. Okay, right, guys, we're not going to get through all the examples today. We do have, for each of the teachers, we've got the full set of solutions on the stage here. And while I remember that, we've also got the resources for next week's grade 8 online session. So all the schools that are here, before you go today, and if you haven't got a teacher here, you must please take these back to school for your grade 8 learners. Have we got Doornkloof learners here today? Doornkloof? Yes, thank you. Tendela? Yes, great. Guys, please make sure you take them. All right, I want someone to help me do this question. Okay, so we've got a circle. And guys, you'll notice something different about this practice exam that we're doing here. I've mixed up the order. And I've mixed up the order to make sure that we cover a bit of everything today. In your exam, all of the geometry will be together. All of the analytical geometry will be together. All right, yes, please. We're going to complete the square. We're going to try and get the circle into some sort of standard form. That's a great idea. Yeah, tell me what you're going to do.
It will be x plus x plus 3 all squared.
Yes.
Plus y minus 5 all squared.
Well done.
Then is equal to 31. 55.
Okay, 31. All right, now let's just talk. Yeah, we're going to add something in. I'm just going to interrupt you slightly quickly here. Remember, guys, when you square, and we've done lots of this, right? What happens when you square inhlanzi plus ekhaya? When you square a fish plus a house, what do you get? Inhlanzi squared, and not just house squared, okay, guys? Let me tell you something now. If I had 1 rand, every Lord, just 1 rand, every time I saw that error, I would be multi-millionaire, okay? And if I was a multi-millionaire, do you know what I would do? I would carry on teaching maths because I love to teach maths. Okay, all right. Guys, what are we missing here? 2 inhlanzi ekai. Okay. And this here, guys, this 2 is ebalulekile. It's very important. This 2 is the reason why this learner did not put a 6 here. They put a 3 because the 3 is going to multiply and it's going to be multiplied by 2. The learner did not put a 10 here. They put a 5 here because they know that it's going to be multiplied by 5. Then what have we also got here, guys? What if we added, if we square out x plus 3, what do we get? We get x squared, yes. We get 6x. What else do we get? We get 9. Now, this here is like an equation. It's like, it is an equation. It's like a set of scales. Nansinkinga, we have a problem. What the learner has done by writing it like this, they've written 9 more on the left-hand side. Our scale is not balanced anymore. But you told me already you fixed it. What are you going to add here? 9. And what are you also going to add? 25. And you actually told me 65. Halala. Well done. Okay. Brilliant. All right. Now you're not finished with the questions, so I'm going to ask you to carry on.
So we're gonna calculate it.
Okay. So the great. Okay, so I'm going to draw a little picture here, guys. I think it's very helpful to have a picture. Okay, that's a terrible circle. I'm going to try and do it a little bit better. Okay, that's a better circle, and I'm going to try and make it a little bit. Okay, that's quite small, isn't it? I'm going to try and make it a little bit bigger. Okay. All right. Okay. You said this, the coordinates of the center are what? -3, +5. I want you all to think about the point 4, 1. Is 4, 1 above and to the left, below and to the right, below and to the left? Where is 4, 1? Is it here? Is it here? Is it here? Is it here? Well done. 4, 1 is somewhere over here. Okay. All right. Then tell me what you're going to do next.
We're gonna calculate the gradient of the radius.
Okay. Let's write down what we're doing here. So the gradient of radius equals what? Is this point over here? Guys, this 4, 1, this is looking like a positive gradient. Something's wrong. Something's gone wrong. This point's not here. Where's the point? It's to the right, but it's actually below this point. 4, 1 is somewhere over here. What's the radius? What's the gradient of the radius? -4/7. Okay, I like that. We have dropped down 4 and we've run across 7. Carry on.
So we're gonna
Yes.
we know
Well done. So this here is a right angle. Well done. So what will the gradient of the tangent be if we want to multiply a number by this to get -1? 7/4. Okay. And all we're going to write here is we just write here radius perpendicular to tangent. Okay. That's a circle geometry idea. But in maths, everything is connected to everything else. Okay, carry on. Okay, y minus y1 equals m into x minus x1, yeah. Yes.
so the equation of the tangent is 7/4.
7/4x minus 6. Did you say minus 6? Oh, sorry. Yeah, this is sorry, this was 7. This was 4. Sorry. So this was 7. Why to be 8?
It will 7 over 4 times 4 is 7.
Yes, -7.
Yeah.
You're absolutely right. Okay. Now, guys, what I'm going to do, I want to quickly draw this picture. Okay, I'm going to draw it properly on my computer. I'm going to ask you guys to help me remember what that equation is. Okay, so what was the circle? It was x squared plus y squared, x squared plus y squared plus, what was it? Help me, guys. 6, was it plus 6x? Minus 10y equals 31. Was that the circle? Yes. Okay, and I'm wanting the gradient. I'm wanting to check whether our tangent is going to go through this point and whether it's going to be a tangent. So 4, 1, all right. I'm just going to zoom out a little bit here. And I'm going to type in the equation that the learner's just given me. He said 7 over 4x. All right, and then he said minus 6. La. Okay, right, next question. It now says, suppose a tangent is drawn from B, another point, to the point of contact with the circle. All right, so we've got our center here was -3, 5. And we've got another point way outside here. It's actually down here somewhere, 12, -4. And the question is, how long is the tangent? Now, Nancy and Kinga, we've got a problem here because I don't know which tangent, which one do they mean? Which tangent do they mean? They want to find the length. Does it matter which one? No, it doesn't matter because we know that tangents from a common point are equal. Cordwa, Nancy and Kinga, we don't know this point. Okay, who can tell me how we can work out the length of this line? We'll call it capital L. No one. Yes, yeah, you've got the microphone. Yeah. Yeah, I'm going to call this point O. I'm going to call this point B.
That was D.
This one here.
Yeah.
Okay.
So from O to T, sir, we have a radius.
Do we know how long it is? Well done. We know it's the square root of 65 from the excellent work done by our first learner. Yeah.
So now we can construct a line from O to B.
From O to B. Yeah.
And we know that from Euclidean geometry that we will have ODB and degree.
Well done. There's a right angle in here. I haven't drawn it very well. My circle looks like an and okay, it's like an egg, not like a circle. All right, but carry on.
So we'll use the distance formula to calculate the length of OB.
Okay, so OB. Do you know what the answer is or not? Have you worked it out?
Of OB?
Yes.
3.
Okay, this is 15 and this is 12. 15 squared is 225. 12 squared is 144. I think this is 369. No, 15 and
3 roots.
3 root 34. Okay, I'll take your word for it. 3 root 34. Okay.
And then
okay. All right. So in fact, we're going to use Pythagoras. So OB, and then we want DB. So what will DB? What will DB squared be? What must I do next?
Open bracket is
Squared or not?
squared.
Yeah. Minus?
Square root in I.
Okay. So in fact, for this, we probably didn't need to square root them in the first place, but never mind, yeah. Okay, and your final answer? 15,52. Okay, I hope that's right. It sounds good. Okay, right. This is a harder question. It's a bit of a different question, maybe. Maybe not. Okay, first part is easy. No, the first part's easy. Snowball. Yeah.
This one. Therefore, it's
This is 0, yeah. Yeah, okay, good.
why?
Huh?
Okay, in order to simulate gradient,
Yeah.
so changing my energy. It should be 2 plus 8 all over 8 minus 0.
Okay.
10 all over 8.
I'm a 5/4.
Yeah.
Okay, cool. All right, excellent. Okay, that's just using our gradient formula. As I say, I don't use the formula. I just say to myself, how much have I gone up? I've gone up 10. How much have I run across? I've run across 8. Okay, so I think you can just get it just by looking at the diagram. Now, this is where it gets a little bit more interesting because they want us to find this angle. Okay, all right. And remember, we've got one little formula here that's going to help us. Let's see. Yeah, let's get. We've got people volunteering their friends here. Yeah. Sorry, y plus? Yeah. Yes. Okay, y equals negative 2x plus 3. So you're putting the straight line into its standard form, yeah? This line has got a gradient of negative 2, yeah? Yeah. Yeah. Okay. And what do you get? What's your answer? Theta is 63,43 degrees. This theta over here, I corner. Okay, not you close, but you're not right. Okay, guys, what I'm going to do, I'm going to put a horizontal line on this diagram. Okay. Yeah, it's not a very good horizontal line, so I'll try again. All right, guys, this angle over here, yeah, we've got some hands up. I want some help here. So I'm going to call this alpha. Okay, because you're on the right track, but this is not quite right. Okay. This theta here. Yeah, but I need you to tell me how you got that. I'm not sure if it's right anyway, but I need you to tell me like what okay, so 180 minus 63, you're saying what? And so what's your answer? 116. I'm liking 116, okay? 116 is not the size of theta though. 116 is the size of alpha, guys. All right, because the tan of alpha is -2. Okay, now as I said to you earlier, I use key. Okay, I'm going to undo tan of 2 and I get 63.4 degrees. Okay, let's just go. I'm just going to round this off. I'm just going to say 63 degrees. That's not the answer, guys. The answer for alpha is 180 minus, because tan is negative in quadrant 2. So 180 minus my key is 11. Yeah, this is actually, I'm going to go with 117 here. 180 minus 116, 180 minus 63, 117. Okay, so alpha is 117. Can you carry on now? I'm going to put another angle on here for you to talk about. Anybody who wants to tell me, how would I find angle B, beta? And if you live in America, guys, they don't say beta, they say beta. Okay, beta. But in South Africa, we say beta.
Okay. So second question.
Yeah.
Bottom. It is everything.
You want me to erase everything? I'm you forward. I don't want to erase everything. Okay. I'm happy to start again. I'm happy to start again over here, but I'm not erasing this. This is very beautiful, yeah.
So
Alpha. Yeah, okay, but we know what alpha is now. Alpha is 117. Okay, can you take it from here? Alpha is 117.
Yeah.
Yes. How?
this equals 51.34.
Okay, I'm just going to write 51 degrees, but I need to know how did you find the angle beta?
So I think
Okay, and what's the gradient? Well done. That's the gradient, guys. That's the gradient of this line. And that's what we just calculated. All right. That's what we calculated in the first part. Okay. Now, well done. What's the size of theta now?
so it's
Yeah, theta is going to be alpha minus beta. Yeah.
it will be
Am I wrong? Okay, I've rounded it off 66. Okay. All right. Well done. Okay. All right. Here's a nice question. I like this question. This says that, guys, these triangles here, firstly, how many triangles are there in this diagram? There are 3. There's this one, and there's the big one. What do they all share? Well done. These triangles all share a perpendicular height, which is somewhere over here. Okay, and now we are told that the ratio of the green triangle, the ratio of the green triangle's area, guys, I made up this question, okay? I am an examiner not for this subject and not for the department, but I am an examiner and I love making up exam questions. So I made up this question. And the question is a mix of Euclidean geometry and analytical geometry. Okay. Now, we know that the ratio of the triangle's areas is 1:2. So for example, if this area is A, this area is 2A. Who can tell me how we can use that to find this point here? What do we know about the ratio of areas of triangles with a shared height? When triangles share a height, their areas are in the same ratio as what? As their bases. Okay, so what's the ratio of this as to this? This must be the same ratio as the areas. It must be 1:2. So this might be P and this might be 2P. Now, earlier today, guys, I taught you a method for finding a point when it's not a midpoint. Okay. What fraction, listen carefully to this, what fraction of the way must I go from A to C? What fraction is B? It's 1:3. All right. B, where must B be? B is 1/3 of the way from A to C. Who can tell me how to find that? B is 1/3 of that distance. And we did do it earlier, guys.
So don't just myself like the some with. But what I did, I said the distance, how much to run across from A to C. I said 17, which I got
15. Okay, guys, so the total travel horizontally is 15. Yeah. Then
And then to get the X and I can divide it by 18. 15 divided by 3.
15 divided by 3 is 5. So this means that this gap here must be 5. So what's the X coordinate of B? Well done. Okay, we're going to add 1/3 of the distance. Then do the same for me with the Y's. Also 15, okay? 1/3 of 15. Well done, Allah. All right. All right. Okay, guys, we're going to, we're just going to quickly just see if we can all just stand up. Just everyone stand up. Stand up, stand up, stand up, stand up, stand up. Okay. Okay, now. Okay, so I'm going to ask you a question, all right? And I'm going to ask you a question. I'm going to say something mathematical, right? And if it's right, you must copy what I do. If it's not right, you mustn't copy what I do. Okay. Right. So x plus x is x squared. Okay. Okay. All right. Okay. Okay. The sine of 90 degrees is what? Wait, my man, the sine of 90 degrees is 1. Is that right? Yes. All of you, put your hands up. The sine of 90 degrees is 1. Okay, all right. Let's go another one. The period, so if you agree with me, you must copy what I do. Okay, the period of a closed graph is 180 degrees. Ah. Okay, guys, the period of a closed graph is 360 degrees. Okay, let's do one more, let's do maybe two more. If, let me just think. If the standard deviation is big, it means that the data is very spread out. Yeah, right, so yes, guys, if the standard deviation is big, the data is spread out. Okay, all right, so 95. Hi, Paul. Look at this. Guys, did you ever see a graph like this before, a trick graph? No. And guys, again, I made up this question. But this question is very nice because that is just a normal trick graph that you're very familiar with. And this is a cost graph that you're very familiar with. And we get this funny looking graph. But let's not panic. It says, what's the period? Okay. And remember what period is? Period is how long does it take to do a wave? Who can tell me what's the period of this graph? And how can you tell me that? When does this graph repeat? From here, when does it start to repeat? When does it get back to the top here? Okay. Do you see, guys? Do you see this shape here? Right? Do you see that shape? And do you guys just watch here? Look at this. Do you see that it is repeating? So how long did it take before it repeated? 360 degrees. The period of this graph is 360 degrees, even though it's a very strange looking graph. Now it says, how would we find the x-intercepts of this graph? How do we find the x-intercepts of any graph? Guys, how do we find the x-intercepts of a graph? Any graph. Well done. We make y equal naught. So now, to find the x-intercepts, we need to solve this equation. And I need your help now, guys. I need you to remind me, how do we solve a trig equation like this? Okay, guys, this is completely in the syllabus. The graph, that funny graph, maybe not so much, although it's a fair question, I think, yeah. How do we solve this equation? So we're trying to solve sine theta equals cos 3 theta. And I'm going to ask someone to tell me. Yes.
If we had the same angle, we would divide.
Well done. Okay. So you've taken the words out of my mouth. If they were both 3 theta, we could divide to make. Is that thing run out of battery? What's happening? Is it working? It's working. Okay. You're 100%. If the angles were the same, we can make tan theta. This one, the angles are not the same. Let's remind ourselves what happens here. Do you know?
Yes.
Okay, good. Tell us.
You try to find another way.
Yes. Yeah. And what co-ratio is very nice. Yes.
So
Well done. Well done. Very, very good. Okay, now that's excellent. Okay. Now, what are we going to do next? Because now it gets a bit more interesting.
so now you work at the quadrants where cos
Well done. I like it.
which is quadrant
Well done.
one. In quadrant one, we take the 90 minus theta. is equal to plus K.
It's K360. Yeah, I'm going to write 360K. If you okay. Well done. K's an element of the integers. Yeah, brilliant.
So now you simplify by transposing 3 theta.
Okay. I much prefer subtracting 3 theta from both sides than this word transposing that a lot of the teachers use in South Africa. Okay. Okay, and then?
You subtract 90 from both sides.
Well, then we subtract 90 from both sides. Okay. Carry on.
So we're looking for theta, not negative. So we have to.
Yeah.
We also divide the
Yeah, it's going to be minus 90K. Yeah. All right. Well done. I'm exceptionally pleased. What are you going to do next? Okay, before we yeah, okay. What about quadrant 4?
Look for quadrant 4.
Okay.
90
Yeah.
equal to 360 minus 3
Yeah. Well done.
plus 360K.
Yeah.
K, the element of each.
Okay, I'm not going to write it again. That's fine. Yeah.
So we have to subtract the and 3 theta from both sides.
Well then, that gives us 2 theta here.
We have to subtract 90 from both sides.
Well done.
And you divide by 2 theta.
Well done. Okay, and that is brilliant. Okay. All right. And now just to show you here, if K in this one, if K is 0, we get 22.5. And that's that first x-intercept. Listen carefully, if K is minus 1, then we end up adding 90 and we get 112.5. All right. If K is 0 here, we get 135. And so we are finding all the x-intercepts of this graph. That was a superb answer. Okay, now proving identities. Hey, yeah, find identities. I love them. Hey, I really love identities. Yeah. Yep.
I proved the left side.
Left hand side, okay? Yeah. Sin theta, no. Yeah, sin theta, yeah.
Minus 10 theta. Cos theta minus plus 5 is.
Yeah. Okay, but just in case maybe there's some people aren't sure what you've done here. What you've done, and it's a brilliant idea, how many terms are on this side, on the left-hand side? There are 2, and on this side, 1. So what you have done is you have combined by adding fractions, these 2 terms. Now we've got Ellie Lord, but just 1 term. Well done. Yeah.
And then is cos theta minus 50.
Sorry. Sin theta cos theta. Sin theta cos theta. Yeah. Okay. Minus sin theta cos theta. Yeah, those are gonna cancel each other out. And So we get cos squared theta minus. Yeah, sorry, so I've left out, just to save a bit of time, I've left that out, yeah, okay? Carry on. Well done. And as I write that down, guys, I know that that is equal to something. What is that equal to? Allah. And what have I got on the bottom? I've got cos 2 theta. Okay. Cos 2 theta. So I've got well done. Okay. Allah. Brilliant. Okay. Guys, don't forget to write equals right hand side. Okay. All right. Now, guys, this now says hence or otherwise. When they say hence, what that means is using part one, see if you can solve this equation. Now, this equation, hey, yes, I'm scared. It looks horrible, but I know that all of that is equal to tan 2 theta. So we've got a question online here with a learner asking, does the 90 minus theta sort of become the reference angle? And yes, in a way that's one way of thinking about it. But basically, the only way that cos can equal cos is if the two angles are equal to one another, all right? Or if the one angle is equal to 360 minus the other angle. Okay, and that's most easily understood. Guys, I'm just deviating slightly here just to help one of the online learners. If we've got something like cos theta equals cos 20, all right, I want you to think of this diagram. Okay, obvious answer here is theta is 20. Anybody can see that. Okay, quarter, and we can add 360. All right, but there's another angle where we get the same answer for 20 for cos. Okay, so in other words, another angle, and the answer is that we must be looking at quadrant 4, and that angle will be over here, and so it will be 360 minus. Okay, so when you've got cos equal to cos, the one option is that the angles are equal, and the other is that the one angle is 360 minus the other angle. Okay, we will put the full set of solutions up to these questions. All right. Here, sorry, we're solving this question. We know that all of this is equal to tan of 2 theta minus 1. Sorry, tan of 2 theta equals minus 1. Yeah. Someone. Just talk into the mic. Is it working? Yeah, okay. Shift 10, okay. Oh, what are we finding? A key angle. Okay, I'm just struggling to hear you. Just try to talk nice and clearly into the microphone. Shift 10 of 1. 45 degrees. Okay. That, guys, is what we call a key angle. It's not the right angle, but it's the right size to get us into the quadrants. Which quadrants do we want to be in? Well done. We want to be in the second and the fourth quadrant. Okay. How do we get into the second quadrant? Yes. Well done. That's 180K, yeah. Well done. And the other one we don't need to worry about because it's tan. Yes, okay, so now what's our answer going to be? 67,5, that's right. So we take 135, we divide by 2 plus 90K. That's our general solution. Now we want to find solutions between minus 180 and 180. So what will they be? Negative 22,5. Well done. Guys, that comes from subtracting 90 and subtracting 90 again. Can we subtract 90 again and stay in this range? In this domain? No. Okay. That's right. If we don't add, in other words, if K is 0, we get 67,5. Or, Allah, well done. Very nicely answered. Okay. Well done. Okay. Now, this is interesting because it's a Euclidean geometry question. It's 5 marks. There's no scaffolding. There's no help. All right, I'm really interested to get an answer from someone. Yeah, and yeah. Greetings.
I see. CT over TM is equal to 80 over 50.
Okay, I'm going to ask you just to pause here quickly. Guys, are these statements equivalent? In other words, if we cross multiply here, do we get this? Yes. Okay, so very nice. Okay. Now, if we could show this, then we can, if we can get to here, then we can get to here. Yes, carry on. Okay, which triangles did you look at? Okay, guys, triangle CDM is this yellow triangle here. And do you see that that triangle is involved with all of those letters? Okay, and then the other triangle that you're saying ADC. Okay, is ADC a triangle? And yes, it is. It's Luhlaza Jengochani. Okay. Our visitors might be interested to know, Fedir and Vladimir, we don't, in isiZulu, there's just one word for blue and for green. It's called Luhlaza, okay? But if we want to say green, and I'm looking to my Zulu friend, my teaching friends, if we want to say green, then we say it's Luhlaza, blue-green, Jengochani, like the grass. So this is blue-green like the grass. If I want to say blue-green, blue, then I say Luhlaza Jengisibakabaka, which means like the sky. Okay, so am I right, guys? Give me a round of applause. Guys, now we're talking about this triangle here, Luhlaza Jengochani. Okay, Jengochani. All right, so we're talking about the green triangle and the yellow triangle. Please carry on, my friend. You're doing a brilliant job. Okay, so what are you going to try and do? You're going to try and prove them? Similar. Okay, angle D is common. Yes. C3 is equal to A2. Why? Tan chord theorem. Good. Yeah, carry on. Okay, so the third angle, so you're saying that this angle over here is equal to that angle over there. this angle here is common, all right? Let's actually give the names of those other angles. It must be which one? Which one haven't I talked about in the yellow triangle? In the yellow triangle, which angle have I not talked about yet? M1. In the green triangle, it's C2 and C3. It's A, C, D. And you said that those are going to be equal because they are third angle of triangle. Hala, 100%. And now what? Okay, I'm just going to check your order because remember the order is it's very important. Okay, so C, D, M, A, D, A, D, C. Yes, hala. Okay, reason? Angle. And now what can we write? Because remember, we're writing it so that the examiner is now going to, okay, now what? Okay, CD over AD equals DM over AC. Why can we do that? Why are we allowed to take the ratios out here? Well done. The triangles are similar. Yep. And then finally, sorry, I think I've messed this up. CD over AD is DM over DC. Sorry, DC. Then we can. So CD squared equals AD times DM. Aha, DM. Okay, hala. Okay, the next question asks us to prove that DM over MA is equal to DC over CB. I'm just writing it up here just so I can see the diagram. Guys, what does that look like? DM, look at this, DM over MA is DC over CB. What does it look like? It looks like proportional intercept theorem. Good, well, are these lines parallel? No. Do you agree, guys? If I can prove this line parallel to this line, then I'm done. Yes. So I want to see if someone can tell me, how am I going to prove those two orange lines parallel? And remember, we've got a few ways of proving lines parallel.
So we're gonna say, who X is equal is equal to X because N is opposite to constant.
Okay, C2 is equal to A2, angles opposite equal sides. Very nice, yeah? Sorry, M2, sorry. C2 equals M2, angles opposite equal sides. Yeah.
And then A1 will be equal to M2.
Angle A1 equals M2. Tan chord theorem. Guys, maybe it helps to turn your book around to see the tan chord theorem. Here, if we make that the tangent, in other words, if we turn the page, then it's easier to see tan chord. Well done. So what now? C2 is equal to A1. And now what? AB parallel to CM
converse of approximate, yeah, are equal.
Converse alternate angles. Okay. All right, well done. Remember, guys, if the lines are parallel, the alternate angles are equal. If the alternate angles are equal, then the lines are parallel. And then the last thing we need to write down is dm over m over ma is equal to dc over cb. And why is that? Proportional intercept theorem. But don't forget, I can never use the proportional intercept theorem without talking about AB parallel CM. La, well done. Right. Okay, we may look at this. Okay. Prove that punk, P-U-N-K, is a cyclic quadrilateral. P-U-N-K. This green quadrilateral, prove that it's a cyclic quadrilateral. And I want us to just quickly, together, how do we prove a quadrilateral is cyclic? There are three ways. Opposite interior angles add to 180 degrees, Norma. Exterior angles equal to opposite interior angle, Norma. Well done. The converse of the angles in the same segment, guys. If we've got this, then there must be a circle through these 4 points. Okay. If there's a circle, these angles are equal. If these angles are equal, there must be a circle. Okay. Take it away. Someone got the microphone. Yeah. Angle. S1 equals angle P1. Why? Angle S1 equals P1. We've got alternate angles. And you said that we've got OS parallel to PN. Yeah. Okay. 100%. Why does S1 equal K2? Well done. So therefore P1 is equal to K2. They both equal angle S1. We don't need a reason for that. So in other words, we've proved this. Yep. Okay. It's a cyclic quadrant, converse, angles, same segment. Well done, very well done. We've got there. Okay, right, now, guys, let's suppose, and I've told you this before, let's suppose you couldn't do this question, part 1. Now, when you go to part 2, you must know that thing is a cyclic quadrilateral. In other words, you can use that it's a cyclic quadrilateral. Now we want to prove that SO is a tangent. And notice, guys, SO looks like a tangent, but the question didn't tell us it's a tangent. How do we prove something is a tangent? Which theorem are we going to use to prove a tangent? How do we prove we've got a tangent? Well done, converse of the tan chord theorem. So what must I, yeah, you do it. See if you can do it.
So C1 called
T1 is equal to K2Y.
those are things in the same segment.
Okay, so in other words, these two are equal. Yes. So T1, this is question number 2. I'm just doing it here so I can see the diagram. T1 equals K2. Angles, same segment. Yes.
Okay, so is K2 equal to P1 is the same segment, which was proved above.
Okay, K2 is P1, yeah, proved, or it's also angle, same segment, yeah.
P1 is equal to S.
Okay. Yeah, we probably don't need to do all these because we've done them already. Okay, yeah, P1 equals S1. And the reason for that is, yeah, alt angles. Yes.
Yeah, okay. Let's say S1 is equal to T1.
S1 equals T1, yes.
Therefore, S1 is equal to 10
Well done, 100%. Okay, nice. Let's turn forward. Okay. Right. We three-dimensional trick. And we've got one word here. What's the one word that I've taught you guys with this stuff? It's my Zulu word for the day. Ibu, ibi, 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 ibu, ibi, ibu, ibu loko. Okay, ibu loko is a bridge, yeah. All right, who's going to tell us how to do this question?
Bridge.
Yeah.
Bridges. A.
Right. So the reason we're calling this a bridge, guys, this side AB is in two different triangles. Okay. And if I can find it, then I can use it in this vertical triangle ABD. Right. Carry on. Okay.
BA is equal to sum of that's the A.
Sine of angle B, yeah, over D, yeah. Okay, I've put in some of the things for you here just to change to the other.
A.
180 minus 2 alpha. All right, guys, 180 minus 2 alpha because these are angles of triangle here. Okay? 180 minus 2 alpha. Yeah.
BA is equal to sine alpha over sine.
Okay, guys, sine of 180 minus 2 alpha. We in quadrant 2, sine is positive in quadrant 2. Okay.
DB is equal to sine alpha over 2 squared alpha.
Yeah.
Already have the grid side. And triangle ABD is a right angle triangle. We are going to use the trigonometric function, which is
Yeah, nice.
over BA the adjacent.
Okay, BA is our bridge side. Hey, yeah. Okay, so guys, that trig ratio is coming out of that purple vertical triangle. Yes, carry on. Yeah, right. Yeah.
And then cross multiply.
Okay, so what do you, yeah. So you got DB equals,
Is equal to
yes. Yeah, I like that, yeah. Yes.
over tan alpha over
Okay, nice.
tan alpha in the no, not
Not that one.
in the denominator divides the one in the numerator.
This one. Okay.
Then I
Okay. And you got the final answer of? Hello, no, very nicely answered. Okay. Okay. Right. So guys, this last question, I made up this question, okay? And I put it in the trial exam here at school. And just two boys got this question right, okay? It requires quite a lot of thinking about sort of basically, yeah, let's just see if we can have a look at what's happening here. So what we've done, we've taken a circle and we've cut out what we call a sector, a slice, like a slice of cake, 60 degrees. And then what we do is we pull these two pieces together. And I should have brought one to show you. When you do that, you get a cone. Okay. When you pull those sides together, the bottom is a circle and you've got a cone. Okay, now the question is, all right, what is the size of the angle which the sides make with the base? Okay, all right. And this, people find this quite hard, okay? Because this edge here, this orange edge, it is going to become this orange circle. Do we see that? Guys, when we close it up, that orange circle on the right, that orange distance on the right is going to become this orange. Okay. Now, if the circle was complete, what's the formula for the circumference of a circle? It's the circumference of the whole circle is 2 pi r. Chord one, what proportion, guys, what proportion is missing? In other words, how much of the circumference have we got? We haven't got the whole circumference. This is 300 degrees. We are missing 1/6. We've got this orange line. This orange line's length is going to be 300 out of 360 times by 2 pi r. Okay, so this orange line, 300 divided by 360 is 5 out of 6. 5 out of 6 times 2 is 5 out of 3. Okay, if you simplify that, you get that. Now, okay. Can anyone tell me what will this length over here be? This length in the cone, what will it be? And this is really asking you to try and just understand how this cone folds up three-dimensionally. That line, guys, is the same as this line. So what length is this line? The red line. It's just r. Okay. And now the last thing we've got to do here. Okay, and so this is a tough question to end with. Okay, but the last thing we've got to do here is we've got to work out what is this here. Do you agree? If we can work this out, then we are good to go. Okay, because then I can find out this angle. Okay, and guys, this is just the radius of a circle with this circumference. Okay, and so remember the formula for circumference is 2 pi r. So 5/3 of pi r must equal 2 pi r. Okay, and the 2 pi r, the r that I'm now talking about, I'm going to call it r1. That's this radius. It's a different radius. So can I work out R1? Yes. If I divide both sides by 2 pi, I get 5 over 3 pi r, and I get 2 pi. Okay, the pi's divide out, and I get 5 over 3 divided by 2, I get 5 over 6 r. So R1 is 5 over 6 r. Okay, and now guys, the last thing here, it's easy to solve this now because I know which trig ratio will involve the adjacent and the hypotenuse. Cos. So the cos of theta will be 5/6 of r over r. It will just be 5/6. And now I can solve for theta, undo cos. Can someone just do it for us on a calculator? Shift cos, second function cos of 5/6. Just shout it last and loud so I can hear. 33.6 degrees. Okay. 5/6, I've rounded it off. Okay. All right. Okay, yeah. So that was probably not a great question to end with, actually. It's quite a tough one. Okay. I do want to, there's a few things that we want to just say to you because so I'm going to stop sharing my screen here, and I'm also going to leave the online meeting. Oh, yes, thank you. Okay, sorry. So Ruth's reminded me, guys, I'm just going to share my screen again. All right. Ruth has reminded me, that's why Ruth's here, to remember all the things that I forget. Okay. Guys, on Tuesday night at 7 p.m. Okay, we will be doing a live stream, a YouTube live stream. And that YouTube live stream we will be working through a paper 2. Last Thursday night, we worked through a paper 1.